already I discussed. N minus 1 P 1 to 10 ns2. N minus 1 P 1 to 10 ns2. Okay. Now, I told you what is the meaning of n minus 1 P 1 to 10. If the ns is 4, then the D sub shall belong to the 3D. Okay. If n is equal to 4, then D belong to the 3D. Okay. 3D में 1 to 10. Now next today let us discuss ionic and atomic size. Now as we are moving from scandium, titanium, vanadium, chromium, then manganese, iron, cobalt, nickel, copper and zinc. In the first series of the transition elements, Now as we are moving from scandium to zinc, atomic number is increasing 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So with increase in the atomic number, what happened? Electrons also increasing. So according to the general trend, atomic size decrease, but here variations are there. With increase in the atomic number, atomic size decreases. So when you reach the mid of the periodic table, it remains same due to the same number of electrons, and then it starts increasing and it will decrease when you reach the zinc. So variations are there, children. As we are moving, the same trend is observed in the atomic radii of the other series also. Now here, this phenomenon associated with the intervention of the 4f orbital, which must be filled before the 5D series of element begin. The filling of 4f orbitals before 5D orbital results in the regular decrease in the atomic radii, that is called lanthanoid contraction. What did I say? The filling of 4f orbitals before 5D. So there is a steady decrease in the size in the lanthanoids and actinoids. There is a steady decrease. So due to that reason, the atomic size decreases. So this phenomenon is known as lanthanoid contraction. Clear, children? Lanthanoid contraction. The next point is ionization enthalpy. Ionization enthalpy depends upon the atomic size. Size decreases, ionization enthalpy increases. So ionization enthalpy is inversely proportional to the atomic size. Now children, there are variations are there in the atomic ionization enthalpy. Due to the increase in the nuclear charge, children, due to the increase in the nuclear charge, now which accompanies the filling of the inner d orbital, there is an increase in ionization enthalpy along the series of the transition elements with the increase in the size of an atom. Okay. However, small variations are there. Now, the irregular trend in the first ionization enthalpy of the 3D metals, that depends upon the atomic size. Now, ionization enthalpy increases and it remains constant, then it increases and decreases. When you reach the end of the series, there is decrease in oxidation enthalpy is inversely proportional to the atomic size. Okay. Now, the unipositive ions have D9 configuration or D10 configuration with no 4s electrons. So, there is a recognition of energy accompanying the ionization with some gains in exchange of energy as the number of electrons increases from the transference of electron into d orbital. So there is a generally expected increasing trend in the values as the effective nuclear charge increases. However, the value of chromium is lower because absence of any change in the d configuration, and the value of Zn higher because it represents an ionization from the 4s level. Okay children, clear? Ionization enthalpy, oxidation states. The next point is we have to discuss about the oxidation state. The most common oxidation state. The most common oxidation state is +3. So along with the +3, the first series of elements they also show +2, +5, +1, +7. Now, the lower oxidation state is due to the involvement of the electrons on the s subshell, that is due to the formation of the ionic bond. And the higher oxidation state +5, +7 is due to the formation of covalent bonds. Clear children? The +7, the higher oxidation states +7 manganese will show, and the +5, +7 it is due to the formation of covalent compound. Sharing of electrons takes place. So the lower oxidation state is due to the involvement of the 4s electrons, and the higher oxidation state is due to the involvement of s electron and also participation of the electrons. So the lower oxidation state corresponds to the participation of the electron from the s subshell, and the higher electrons are due to the participation of the d subshell. Okay children, clear? Now, so the higher oxidation state mainly due to the formation of covalent bonds, and the lower oxidation state is due to the formation of ionic bonds. So the element with the greatest number of oxidation states occur in or the middle of the series. Manganese, for example, it exhibits all the oxidation states. Manganese, it exhibits all the oxidation states starting from +2 to +7. Okay, +2 to +7, the higher manganese. Now, the lesser number of the oxidation state at the extreme end, from either too few electrons to lose or share. Scandium and titanium, you have to give the example. The variability of the oxidation state is a characteristic property of transition elements. So why they show variability? That is one of the characteristic property of the transition elements. Now this variability in the oxidation state of transition elements is due to the incompletely filled d subshell, or due to the involvement of the ns and d electrons. Actually, only the reason is why they show variable oxidation state. Simply you can say due to the incompletely filled d subshell. Okay children, clear?